Hello guys, we're back with our next lecture. In this lecture, let us go through the next topic. That is, we'll be continuing with some basic terminology with respect to TOC, guys. Okay, so before starting finite automata, I think these are really important to understand. So that's the reason why I'm discussing them. Okay, yes. So in this lecture, we'll be discussing in detail about clean closure, positive closure, and some basic operations on language like complement, reverse, those type of things. Okay, yes. So I think when we want to learn about clean closure and positive closure, we need to understand a few things, guys. Okay, so I just took a small piece of paper, guys. So let us start. Okay, yes. So let us start. Okay, so let us start performing some operations, guys. So assume that our given language is I think it's not clear. Let's just give me a second. Yeah, now it's a bit clear. Why it is having that much brightness? Okay, so now it has been reduced. Okay, yes. Okay, so now assume that this is our closure, right? So sigma is equals to a comma b. So this is our particular alphabets which we have taken. Okay, so now if we assume sigma power 0, okay, means this is multiplied 0 times, means indirectly it's going to be an empty item, right? So that is nothing but you will get empty epsilon as a result, right? So if I perform sigma once, I will get a comma b, right? Yes. So if I perform sigma 2 is nothing but sigma into sigma. So if I multiply this with this, what I will get is I will get all the combinations, right? So AA, AB, BA, BB. Okay. Similarly, if I perform it thrice, I'm going to get a sigma into sigma square. I can directly perform it or I can write it in this way also, right? So triple A, B. Okay. So then A, B, A. I'm writing 0001 in that fashion. So then A, B, B. Then B, A. Okay. So after that B, A, B, 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 A. After that B, B, B. So this is 1, 2, 3, 4, 5, 6, 7, 8. Yes, absolutely correct. Okay. So in this way we can continue, right? Yes. So when we are talking about clean closure, please remember these terms. I guess I don't know based on which language they designed this. So clean closure means it is a union of sigma naught union, sigma 1 union, sigma 2 union, and so on up to sigma n. So indirectly in the clean closure we are going to include all possible things, guys. Okay, so means to be clear, it is starting from 0, right? So the length of the item might be 0 to anything, right? Yes. And when it comes to positive closure, so this is clean closure, and the symbol for this is a sigma star, guys. So star value might be 0 to infinity, okay, or 0 to n. Okay, moving on to positive closure. In positive closure, we are not going to include this or not. That's it. So sigma 1 union, sigma 2 union, and so on up to sigma n. So indirectly it will represent it in this way, and it starts from 1 to n. So this is 0 to n, that is 1 to n. So this is the only difference in between this positive closure and clean closure. If you want more idea, so in this particular clean closure, we will have epsilon because 0 length is allowed, but here the length should be 1 minimum. So here sigma is not allowed. Got it? Yes, so that is the major difference with respect to this clean closure and positive closure, guys. The reason why I'm stressing in on this is so this particular thing might be asked in various ways, guys. In many questions you can observe it, but most students might confuse in between these two terminologies, and I know that. So that is the reason why I'm stressing on this particular thing. Okay. Yes. So now let us take few things with respect to language. Okay. So now what is a complement of a language, guys? So what I told here, so sigma star is everything, right? So if a sigma star is everything, so if I subtract from a sigma star my original language, so this is my original language and this is my complemented language. So if I remove the language which I am using from this whole language world, I am going to get complement, right? Yes. So that is what language complement, guys. Got it? Yes. You understood, right? So what I'm trying to say, so basically if the given question is they told that this is the language, so at that time what will be complement? So this will be complement, this will be complement, this will be complement, and so on up to infinity. So every one of them will be complement. So that is nothing but sigma star minus L. Got it? Yes. So in the same way I think we can conclude few things here, right? So L union L complement, so this is nothing but sigma star. Similarly L intersection L complement, so this would be 5. So these are some kind of set properties. I think everyone can recall them, right? Yes. Okay. So now moving on to reverse. So assume that the given language is AB, CA and CD. Okay. So now what will be the reverse of this, guys? So it will be BA, AC and DC, right? Yes. So that's nothing but the reverse. So we are just reversing the string. And what about concatenation? So if you want to perform L1, L2, where L1 is a comma B or AB, and L2 is a comma C. Okay, so let us assume this as AB, so that will be easy for us. So just to multiply them individually, guys. So what will be the result? So it is AB A and AB C. So these are the two answers, right? So here assume that there is no comma. Okay, so at that time this will be the answer. So this is about working with the language and the concept of a clean closure and positive closure, guys. Okay, I know that the video is really small when compared to our traditional ways of teaching. So now I hope everyone got a clear idea with respect to this, right? Yes. So the only thing which I want is the clarity on these terminologies, guys. Okay. Yes. So in the next lecture, we'll be starting our first lecture about finite automata, guys. So the flow will be in this way. So all these topics belongs to this finite automata only, like regular language, to be clear. Okay. So first we'll be discussing about finite automata. Then we'll be moving on to regular language. Then we'll be moving on to regular grammar. So if you recall, so this is the first layer, guys. Finite automata, regular language, and regular grammar. So in this way we will complete. After that this, after that this. So in that way we will continue, guys. Okay. Yes. So in the next lecture, let us start our discussion with respect to finite automata. I'll be explaining you about this diagram later on. Okay. Yes. So in the next lecture, let us start our discussion with finite automata, and from now on, every lecture will be linked, guys. So even if you miss a single lecture, it will be really tough for you to understand the things, okay? So please concentrate while solving the questions. We'll be solving each and every question, and please maintain a book for this, guys. It might be rough book or any kind of book, but you need to practice them while I'm teaching them, okay? Yes. So I hope everyone got a clear idea. So in the next lecture, let us continue with the basics of finite automata, okay? Yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share, and subscribe for more awesome videos like this. Thank you.